The mystery of the Great Pyramid's construction. Beyond the conventional intro, gaze upon it, a colossal monument of stone, piercing the desert sky for over 4.5 millennia. It is the Great Pyramid of Giza, the last surviving wonder of the ancient world for centuries. Its sheer scale, its staggering precision, and the sheer audacity of its creation have defied simple explanation. How did a Bronze Age civilization, without iron tools, wheeled vehicles, or advanced machinery, lift millions of multi-ton blocks to such dizzying heights and place them with pinpoint accuracy? Conventional theories offer fascinating insights, but they often leave nagging questions, details that simply don't seem to add up. What if there's more to the story? What if the answers lie beyond the conventional understanding of ancient capabilities? Join us on Adventure Hidden as we embark on an epic quest to unravel the greatest engineering mystery of all time. Over the next hours, we will delve into the astonishing facts of the pyramid's construction, examine the prevailing theories, and then boldly venture into the realms of lost technology, forgotten knowledge, and astronomical precision that continue to challenge our modern assumptions about the brilliance of the ancient Egyptians. Prepare to have your understanding of history forever changed. Chapter 1. The Scale of the Challenge. What we know. To truly appreciate the mystery, we must first confront the astounding facts of the Great Pyramid of Giza, built for Pharaoh Khufu around 2580–2560 BC. This monumental structure stands as a testament to an ambition almost incomprehensible. It originally stood 146.6 meters, 481 feet tall, a height unsurpassed for over 3,800 years. Its base covers an astonishing 5.5 hectares, 13.6 acres, roughly the size of 7 football fields, but it's the sheer volume and weight of the materials that truly boggle the mind. Estimates suggest the pyramid is composed of approximately 2.3 million stone blocks. While the average block weighs a staggering 2.5 tons, 5,000 pounds, some of the colossal granite blocks used in the king's chamber and above it weigh anywhere from 25 to 80 tons. Imagine moving just one of these colossal stones, let alone millions, and lifting them hundreds of feet into the air, and all of this, according to mainstream archaeology, was accomplished in a remarkably short time frame, roughly 20 years. This means that, on average, a block would have been quarried, transported, and set into place every 2 to 3 minutes, 24 hours a day. For 2 decades, the precision is equally much. The pyramid's base is incredibly level, with variations of less than an inch across its entire 13-acre footprint. Its 4 sides are almost perfectly aligned with the cardinal points of the compass, with an astonishing accuracy of less than 1 degree from true north. The joints between many of the casing stones, which are no longer present but documented, were so fine that a razor blade could barely fit between them. The technological context of the time adds another layer of perplexity. This was the Bronze Age. The Egyptians had no iron tools, only softer copper chisels and saws, along with stone pounders for quarrying. They had not yet invented the wheel for heavy transport, though rollers and sledges were used. There's no evidence of sophisticated pulleys or counterweights for lifting, beyond simple levers. Furthermore, archaeological evidence suggests the pyramid was built not by slaves, but by a highly organized, well-fed, and perhaps even paid workforce of skilled craftsmen, laborers, and support personnel, tens of thousands of them. While we have the what, the how remains the greatest challenge. Chapter 2. Conventional theories, ramps, levers, and manpower. For centuries, archaeologists and engineers have proposed various conventional theories to explain the construction of the Great Pyramid, relying on the known technologies and organizational capabilities of the ancient Egyptians. These theories primarily revolve around the use of ramps, simple levers, and immense manpower. The most popular conventional explanations involve some form of ramp system. The straight ramp. This theory suggests a single, enormous ramp running straight up one side of the pyramid. However, calculations show that such a ramp would need to be over a mile long to achieve a manageable gradient, requiring more material than the pyramid itself, and would have been incredibly unstable at height. The spiral ramp external. This proposes a ramp spiraling up the outside of the pyramid. While more feasible in terms of length, it would have obscured the builder's view of the pyramid's corners and overall geometry, making precision difficult. The turns would also have been incredibly tight for moving multi-ton blocks. The internal ramp. Jean-Pierre theory. This is perhaps the most compelling conventional theory, proposed by French architect Jean-Pierre Houdin. He suggests that an external straight ramp was used for the lower third of the pyramid, but for the upper 2/3, an internal, spiral ramp was built within the pyramid's core. This ramp would have a manageable gradient and specific turning points at the corners. Houdin points to a subtle notch or indentation visible at the northeast corner, which he suggests was a turnaround point for the ramp. This theory elegantly explains how blocks could have been lifted high while maintaining clear sight lines for precision, and it requires less external material. However, direct evidence of such an internal ramp remains elusive, though the Scam Pyramids project has found intriguing internal structures beyond ramps. Simple machines like levers were undoubtedly used, especially for positioning blocks at the lower levels. By placing a fulcrum under one end of a block, it could be walked or rocked into place with fewer men. For moving blocks over flat ground, sledges pulled over lubricated surfaces, wet sand, or mud, and rollers made of tree trunks were likely employed. While these conventional theories demonstrate ingenuity and immense human effort, critics argue they still struggle to fully account for the extraordinary precision of the upper courses. The placement of the massive King's Chamber granite blocks, and the sheer speed required for construction within a 20-year time frame using only known Bronze Age tools. This persistent gap in understanding is what drives the search beyond the conventional. Chapter 3: Unconventional Theories, Lost Technology, and Esoteric Knowledge. The persistent questions surrounding the Great Pyramid's construction have given rise to a fascinating array of unconventional theories, often venturing into realms of lost, ancient high technology, esoteric knowledge, or even, for some, extraterrestrial intervention. These ideas, while often lacking mainstream archaeological consensus, compel us to reconsider what ancient civilizations might have truly been capable of. One of the most intriguing unconventional theories proposes that the Egyptians possessed a lost technology that allowed for the cutting and manipulation of stone with a precision far beyond what copper tools should permit. Proponents point to the incredibly smooth surfaces of granite, the straightness of cuts, and the apparent drill marks found on some ancient Egyptian artifacts, which seem to suggest a power tool-like precision. How could soft copper achieve such feats on hard granite and diorite? Some speculate about forgotten methods of sound or vibration technology, suggesting the ancients used resonant frequencies to soften or levitate stones. While this sounds like science fiction, the idea that certain frequencies can affect materials has modern parallels, though its application to pyramid building is purely speculative. Edward Leete-Scolan's Coral Castle in Florida, a modern structure built by one man, allegedly using unknown methods to move massive stones, is often cited as a parallel, though his methods remain debated. Another highly debated, yet scientifically intriguing unconventional theory comes from materials scientist Joseph Davidovits, who proposes the Geopolymer theory. Davidovits suggests that many of the pyramid's limestone blocks were not quarried and then hoisted, but rather were cast on-site using a form of ancient concrete. He argues that the Egyptians mixed a specific type of limestone with natural binders, creating a slurry that was then poured into molds. This process, he claims, would explain the remarkable uniformity of the blocks, the incredibly tight joints as they would simply mold against each other, and the presence of organic materials, like hair found within some pyramid stones, which would be unlikely in quarried rock. While Davidovits has produced synthetic geopolymus resembling pyramid stones, and some scientific analyses support his claims, the theory remains highly controversial within Egyptology, as it challenges the traditional view of stone quarrying. In Transport. Other, more speculative ideas include water-based theories, suggesting intricate systems of locks and canals were used to float massive blocks up to desired levels using buoyancy. While ingenious, the scale of such a system on the Giza Plateau and the mechanics of controlling water at such heights pose significant practical challenges. Then there are energy or resonance theories, viewing the pyramid as a giant energy condenser or power plant, suggesting its very geometry was designed to accumulate or focus an unknown energy that aided its construction. While these ideas often border on pseudoscientific fantasy, they arise from the sheer baffling nature of the pyramids' accomplishments, driving some to seek answers beyond the conventional boundaries of what we believe was possible in antiquity. Chapter 4: The Precision Problem, Astronomical Alignments and Anomalies Beyond the Sheer Volume and Weight of the Blocks. It's the astonishing precision embedded within the Great Pyramid's construction that poses one of the greatest challenges to conventional understanding, often driving researchers to consider beyond the conventional explanations. This precision far exceeds what seems possible with the known tools and techniques of the Bronze Age. Firstly, the pyramid's cardinal alignment is almost unbelievably accurate. Its four sides are aligned to true north, south, east, and west, with an average error of less than 1/10 of a degree. This precision surpasses that of many modern structures. How did ancient builders, without compasses or advanced surveying equipment, achieve such pinpoint accuracy? Conventional explanations involve observations of circumpolar stars like Thuban, the North Star of that era, and elaborate sighting techniques using plumb bobs and sighting lines. While theoretically possible, the execution on such a massive scale, with such minute error, remains a testament to incredible skill. Secondly, the leveling of the base is phenomenal. The Great Pyramid's foundation is almost perfectly level, with variations of only about 2.1 centimeters (0.8 inches) across its entire 13.6-acre footprint. This is an engineering marvel. Theories suggest the use of water-filled trenches or incredibly precise land leveling techniques, but achieving such accuracy over such a vast, irregular terrain is still mind-boggling. Then there are the tightness of the joints. The casing stones, which originally covered the pyramid and created its smooth, polished surface, were cut and fitted with such precision that the gap between them was often less than the thickness of a razor blade. This is particularly perplexing, given the use of relatively soft copper tools for shaping and finishing hard limestone. How could they achieve such fine tolerances without modern grinding or polishing equipment? Inside the pyramid, the king's chamber presents further anomalies. It's built almost entirely of hard granite, with blocks weighing up to 80 tons. The precision with which these massive blocks were cut and fitted, and then raised to a height of over 40 meters, 130 feet, continues to baffle engineers. The air shafts, now thought to be for stellar alignment or ritualistic purposes, rather than ventilation leading from the king's and queen's chambers, also demonstrate precise angles and straightness over significant distances. These extraordinary feats of precision, combined with the scale and speed of construction, lead many to question if our current understanding of Bronze Age technology is truly complete. They suggest that the Egyptians either possessed an unknown mastery of existing tools or had access to methods and knowledge that have been lost to history. Chapter 5. The Enduring Allure, Modern Research, and the Search for Answers. Despite centuries of study, the Great Pyramid of Giza continues to hold its secrets, maintaining an enduring allure for researchers, adventurers, and the curious public. Modern science and technology are now providing new ways to probe its mysteries, pushing the boundaries of conventional understanding and reigniting the search for answers. One of the most significant recent initiatives is the Scam Pyramids project, using non-invasive techniques like moin tomography, which detects subatomic particles that pass through stone, infrared thermography, and 3D reconstruction. Researchers are able to see inside the pyramid without disturbing its structure. This project led to the groundbreaking discovery of the Big Void in 2017, a massive, previously unknown chamber above the Grand Gallery. While the void's purpose and contents remain unknown, such discoveries continue to reshape our understanding of the pyramid's internal structure and potentially offer new clues about its construction methods. Could this void have been part of an internal ramp system? Or did it serve another, still mysterious, purpose? Experimental archaeology also plays a crucial role in trying to solve the puzzle. Teams of engineers and enthusiasts have attempted to replicate ancient building techniques, moving multi-ton blocks with simple tools, ropes, and sledges. While these experiments have shown that many aspects of pyramid construction are physically possible with known ancient technology, they often demonstrate the immense difficulty, the slow pace, and the practical challenges of achieving the required scale and precision, especially for the upper levels. These experiments highlight both the ingenuity of the ancient Egyptians and the limitations of our current understanding of their exact methods. Furthermore, digital modeling and virtual reality VR are allowing researchers to simulate various construction scenarios, testing the feasibility of different ramp systems and lifting techniques in a virtual environment. This allows for rapid iteration and analysis of theories. The enduring allure of the Great Pyramid lies in its ability to humble us, to challenge our assumptions about what ancient civilizations could achieve. It represents a pinnacle of human ambition, organization, and perhaps a lost wisdom. The ongoing research continues to peel back layers of its mystery, shifting the focus from purely fantastical alien theories to a more nuanced appreciation of human ingenuity, whether through rediscovered methods, overlooked natural phenomena, or a more sophisticated understanding of their already known tools. The Great Pyramid remains a powerful symbol of humanity's past achievements and an unending source of fascination, perpetually inviting us to look beyond the conventional. For its timeless secrets, outro our journey into the heart of the Great Pyramid's construction mystery reveals a paradox. We know so much, yet understand so little. We stand in awe of its impossible scale, its breathtaking precision, and the sheer audacity of its builders. While conventional theories offer compelling insights, they often leave tantalizing gaps, prompting us to peer beyond the conventional for answers that still elude us. Whether through lost technology, forgotten knowledge, or an unprecedented mastery of known tools, the builders of the Great Pyramid achieved a feat that continues to challenge the limits of our imagination. It reminds us that history is not always a linear progression, and that ancient civilizations may have possessed knowledge and capabilities that have been lost to the sands of time. The Great Pyramid stands not just as a tomb, but as an eternal question mark, a symbol of human genius and an enduring invitation to keep exploring, keep questioning, and keep seeking the hidden truths that lie beneath the surface of history. This has been Adventure Hidden, and we hope you continue to seek the extraordinary in the annals of time.